I'm Chili. Hello world. We're on YouTube live. Fortunately, nobody knows the button to see us live except for me. But you guys can check out recordings later. So I will add a link to my YouTube channel under other resources. I added this page today, and I'll continually add stuff that's not directly related to our book stuff in here. So for example, we have some math toys we're going to play with today. And so I have online versions of those toys here. And this image right here is, for those of you who have the workbooks, there's a 2-card set that has this in the back of your workbook. And I'll get people a color version of this. I forgot to print it today by Wednesday. These are called attribute pieces, as you can see upside down here at the bottom. And there's all different kinds of attribute pieces. So an attribute is just an attribute. Let's see, how do I define attribute, right? An attribute is a characteristic. What's a characteristic? Well, for example, male or female, short or tall, blue-eyed, dark hair, long hair, just ways we categorize. So this particular set has 1, 2, 3, 4 different shapes, 4 different colors, and if you'll notice, it has 2 different sizes. So 4 options times 4 options times 2 options. 4 times 4 is 16, times 2 is 32. That means there must be 32 of these suckers here. If you go to a math toy shop, believe it or not, they exist, and you go to find attribute pieces like to give to one of your nieces or nephews or kids, there's all different kinds. Some of them come in, they're plastic usually, and there's thicknesses. There's fat ones and there's skinny ones. And so there's all different styles of attribute pieces, but they're just things we can put in categories to help. And that's a big part of math, categorizing stuff and sorting things out. And so that's what we're going to take a look at toward the end of class today. Okay, so that page will continue to grow. For now, we are going to go on a magical adventure to the world of Foria. And you guys are going to travel back in time in Foria to when you're in 1st grade again. So welcome to 1st grade at Foria Elementary School. We're going to practice counting today and writing our numerals. You ready for this? I have a pen and piece of paper out. I got my crayons today. I'm sorry. That's okay. All right. So we're going to practice counting and writing our numerals. So for now, I will write them. You can just watch. Don't worry about copying them yet. But I just need you to recite our numerals with me, right? We're counting people in a room. Ready? So 1. Oh, that's not a pen. Sorry. Try again. 1, 2, 3, 4. Good. And the next is 5. Excellent. Good job. And what's next? 6. No, we're not up to 12 yet here, but we'll get there. Don't worry. Okay, let's see. What's after 6? 7. Good. And then 8. Excellent. Oh, you did such a good job counting to 8 today in Foria. So let's leave Foria for a minute and look at Foria as we're like journalists here, maybe. Does Foria have a different number system than we have on Earth here? Yes. Okay. So how many digits do they appear to have? What's that?
It's base 4.
It's base 4. Okay, yes. So this is a base 4 number system. Base 4. So how many digits are there? 4 digits. What are the digits we have to work with?
0, 1, 2.
0, 1, 2. Oops, that's supposed to be a 1. My brain got ahead of my hand. 1, 2, and 3. Now, not only is it a base 4 number system, but it's also a place value number system. So that's important. So it's base 4 and it's place value. Now, usually base place value systems have the same number of digits as the grouping amounts. So not only do we have 4 digits, but we're also grouping by 4. Groupings by 4. So once we get a group of 4, we have to jump up to the next place, which you should notice we did right here. Okay. So every number system has to have a ones place. So place value systems. You can write stuff down now if you want. It's a good idea. We'll come back to counting in base 4. So place value systems, we'll just use the base 4, for example, and then we'll relate it to our base 10. Generally, the first place is the ones place. You got to start somewhere. Then it's whatever you decide to group by. Now, we normally group by 10, but computers group by what? 2. Yeah. When colors were made to work with computers, they started to group, instead of by 2, they grouped, does anyone remember from last class? What we group for colors digitally?
8.
Almost 16. Yeah, so with colors we group by 16. When we're telling time, at first, what do we group by? 60, right? There's 60 seconds in a minute, 60 minutes in an hour, but then all of a sudden we have 12 hours or 24 hours in a day. Okay, so it's all about grouping. If we're in a base 4 system, then we would, after the ones, we would start grouping by 4. Okay. So you remember tally marks when you're writing stuff down? We usually do those in 5s. But a base 4 system, they would do something like 1, 2, 3, there's a group of 4. 1, 2, 3, there's another group of 4. Okay. And then maybe they count a couple of more. So if I had that many things I was keeping track of in a base 4 number system, how many groups of 4 did I tally up here? So there are 2 groups of 4. How many ones? 2. So in base 4, they would write this many things, this many, as a 2, 2, which means 2 groups of 4 and 2 ones. So if I expand that out, I have 2 groups of 4 and I have 2 groups of 1. So all of a sudden, though, I'm going to have a bunch of groups of 4. So what's the next grouping here? Can you guess? 1s, 4s, and then? It's okay to be wrong. I learn every day. Ask my daughters. What are we grouping by here? 4. So I got 4 1s, and I had to jump up to this place. Once I get another group of 4, I'm going to jump up to the next place. What is it? Almost, not 8. That would be 2 groups of 4. What are we grouping by? Not 2, but 4. Yeah, it'd be 16 because I want 4 groups of 4. Yeah, so the next place would be the 16s. Anybody want to take a stab at what the next group is going to have to be?
32.
Not 32s, but 64s, because I need it. Once I get another group of 4, I jump. And so 64s would be next in a base 4 system. Now, if you think about that, another way to look at it, so I'm going to use base 10 notation for a minute. This symbol right there in blue doesn't exist in a base 4 system. They would write that as 1, 0. But I could say this place value is 4 to the first, this place value is 4 to the second, and this place value is 4 to the third. The 1's place value you could call 4 to the 0, because remember, something to the power 0 is really 1. Okay. So whatever you're grouping by, in this case 4s, that's the powers that represent your place values. So if we were doing a base 8 system, like I think you had in the homework yesterday, it would be your 1s, your 8s, your 8 squareds, your 8 16s, whatever they happen to be. Okay, so we'll do other number systems in a minute. If this was a base 5 place value system, what would I have instead of 16s in a base 5 system? 25s, because it's the 5 squared, 5 groups of 5. Yeah. In our number system, it's 10 groups of 10, which we call 100. Okay. Now, in the homework and in the workbook, you're going to see a lot of numbers that look weird because we're using a different base. Anytime we're talking about a different base, we need to make a little note of what system we're in. Otherwise, when I look at that without the underscore, subscript 4, I think that's 2 10s and 2 1s, right? 22. When in fact, this is not. This is this is really what we would call 10. Okay, so the way we look at it and say it's going to be confusing for a couple of days until we get done with this unit and move on to other stuff. So usually when I read these, I don't call that 10, and I usually don't call it 4 either. So I would do something like this. This is 1, 2, 3, and then I call that one 1T. How much is 1T? It's that many. Okay. And then this would be 1T1, 1T2, 1T3, 2T. Okay. So just for fun, we'll speak them a little bit different. All right. So let's try counting again together in base 4, starting over. And then we'll double check. So we're going to try to do the first 15 counting numerals in base 4. Yeah, first 15. So we've got, ready? 1, 2, 3.
10.
Not 10, 1T. Yeah, let's call it 1T, which is also 4 in English, right? All right, and then we got 1T1, 1T2, 1T3, 2T. And then 2T1, 2T2, 2T3, and then 3T. And then 3T1, 3T2, 3T3. I'm going to pause there. Where am I at? All this 3T stuff got me a little confused. If I want to translate this to somebody, what would I tell them that digit right there means? It's not just a 3, it's 3 whats? 3 4s. So that really means 3 4s and
3 1s.
3 1s, yeah. Okay, so 3 4s is 12 plus 3. Hey, I did it. I got up to 15. So don't say anything out loud right now, but what I'd like you to do is I'd like you to write down what numeral do you think comes next? Write something down. And then we'll check it to see if it works. So just write something down. Don't worry about it being right or wrong. So off the top of my head, my gut reaction is to say 40. But I can't. Why?
Because next spot is 16.
Yeah, I ran out of groups of. I got to jump. The 3 is like a 9 because it's the last digit. Okay, and the symbol for 4 doesn't exist in this number system. Okay, so the key is once I get to that place, that's like a 9. I have to jump to the next place value. So that's like a 9 here. I have to jump up. So just keep in mind, in this number system, if I take a 3 plus a 1, what does that have to equal? 4 or 1T, right? Okay. So with that in mind, if I'm at 3T3 and I add 1, we all know about carrying, right? Okay, so let's make believe we're now like, this would be like 3rd grade. 3 plus 1 is 1T. We write the 0, carry the 1. And then 3 plus 1 is 1T. And like you said, Kristen, we have to jump to the next place, to the 16th position. What's 4 groups of 4? 16. Yeah. All right, let's count a little farther. What's the next number? 101. We don't want to call it 100 because that makes me think of 1010. So we're just going to call it 101. If you want a cute name, like instead of 1T, we could call it Wondered. So that's Wondered 1, and then Wondered 2, and then Wondered 3. What's after Wondered 3? Almost. No, not quite that high yet. What's after just the 3?
Wondered 1T.
Wondered 1T would be next, and eventually we're going to get to Wondered 1T1, which I always thought was a cute number. So Wondered 1T would be next. Now let's just double check that we're in the right spot. This number right here is what in base 10 we would call 16, right? So 17, 18, 19, that should be 20 right there. Okay, let's double check that it is 20. I'm going to move some stuff out of the way here. Black. So naming each of these place values. The leftmost place value is what position? 1s, 4s, or 16s. It's 16s, right? So this says I have one group of 16, and what's the next one say?
4.
One group of 4. And the last one I said has no 1s. And I usually just explicitly say, yeah, I've got no 1s. Okay, so really this is a 16 and a 4, which altogether in our number system is a 20. So yeah, it worked out. Does this feel very strange and confusing? Taylor? Totally, yeah, it's totally confusing. Little kids gotta learn each of these places and these digits and these names. It's a lot. And then we go and screw them up because like 21, 22, 23, that makes perfect sense. But then we have words like 11, 12, and 13, right? So our number system is quite bizarre the way we speak it and the way we put it together. It takes a lot of getting used to. So I'm throwing you back into kindergarten, first grade, where you're looking at these things and this makes no sense to me. And you're confused and you want to go cry and have a cookie and take a nap, right? All right, so I promise I won't make anyone cry. I can't make that promise. I will try really hard. All right, so let's go back to base 10 for a minute, which is our standard number system. So in our base 10 place value number system, couple of things we have to remind ourselves. We group by 10. It's all about grouping. Additionally, we have exactly 10 digits. Those digits are 0, 1 through 9. Now, we've gotten very used to this system and the places, but we're going to just explore those out a little bit more by reminding ourselves of the basic places. Let's look at the first 5 places, for example. We've got our 1s, and every number system has got to have some 1s in it. You got to start somewhere. And then you start grouping. We choose to group by 10s. Right, so we have our 10s next. And then once we get a group of 10 10s, that's our hundreds. 10 10s could be expressed as 10 to the second power. Then we get 10 hundreds, which we call thousands. To the third power. And then we get 10 of those, which has not really a special name, it's just called 10 thousands. And what's after 10 thousands?
100,000.
100,000s. And after that is a million. I thought it was 1,000,000. It's not. Really? You're sure? Okay, a million. Couldn't it be 1,000,000 though? Let's double check, right? There's 10,000s, then 100,000s. 1,000,000 makes sense, okay? Do most cultures in the world use the same system as we do? Most, but not all. We like to use commas to separate groups of 3. Other countries like to use commas as their decimal point. So when they come to this country and they see us writing commas all over the place, that would be like us writing decimal points all over the place. Would that freak you out if you saw more than one decimal place in a number? Kind of weird. Other places, billion is not the same as we call a billion. Instead of going by groups of 3, they go by groups of 6. So they get their millions, and they would need a million to get a billion. A billion for us is 1,000 million, because we go by 3 places, and 1,000 has how many zeros?
0.
3 zeros, yeah. So there are different ways of organizing base 10 numbers, and there are different ways of talking about them. Not every country does it the same way. My recollection is in France, they use their comma as a decimal point. They space things out. So if, like, for a million, they would write it like this. They would just put a little extra space to make it more readable instead of commas, because they use a comma for the decimal point and 23 cents. Okay, so slightly different notation. And I'm pretty sure they have a different, billion means a different thing for us. For us, a billion is 1,000 million. For them, it's a million. So the word billion does not mean the same dollar amount. Okay, next. Expanded form of a number. We've kind of looked at that a little bit. Expanded form just means explicitly name the place values. So, for example, it is 2017 right now. That's kind of a complicated number. It means 2 1,000s and no 100s and 1 10 and 7 1s. So when we name each place value, that's what we call expanded form. This one right here, that's standard form. Okay, so we have standard form, we have expanded form. And the way to convert a particular other base to our system is to just think of it in expanded form. So we're going to try that for computer notation, which is binary. So this is one of the homework questions you'll see. Binary numbers. Binary numbers is base 2. It's what computers use. So in base 2, what are they grouping by? 2. Yeah, so every time I pick up a new number system, I always have to remind myself of a couple of things. First thing I remind myself of is what am I grouping by? And here we group by 2. Other thing I want to remind myself of, what are the digits I have to work with? And here we only have 2 digits. 0 has always got to be one of them, otherwise place values don't work. And then, well, that leaves me only one other digit to use. I can only work with 0s and 1s. Okay. Then I start thinking, okay, if I'm grouping by 2, what are my place values? So let's list out, say, the first 5. 1, 2, 3, 4, 5. The first place has to be what?
1.
Has to be 1s. The next place is always what you're grouping by. What am I grouping by? 2s. Then I just keep grouping by 2 to name the next places. So next group would be 2 groups of 2. That would be our 4s. 2 groups of 4s? 8s. And 2 groups of 8? 16s. Oops, I'll write it that way. I wanted to use the word 16. Thinking about this in terms of powers, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth would be the 16s. The 1s would be what?
2 to the 0.
2 to the 0. Yeah, it's always whatever base to the 0. So we always have our 1s, then we have our base, then we start grouping by our base to get other places. Okay, so I'm just going to write down a number in base 2 and see if we can figure out what number I wrote down. So hopefully everyone got this written down. Okay. So let's try 1, 0, 1, 0, 1. And then I should make a note that this is a base 2 numeral. So now we have to dissect it. So I'm going to start on the left side. So I'm going to write over here there is 1, 1. Right? Then next to that I have 0 whats? 0 2s. Next to that I have 1 4. Next to that I have no 8s. And next to that I have 1 16. No. So let's see, what do we got? We have 16 and 4 and 1, 21. So this is what a computer notes when we have a group of 21 things. Usually if there's nothing written down, assume it's base 10. Every once in a while I write it in there just to remind myself that's base 10. So taking a number in a foreign base and converting it is just a matter of being able to name each place value. If you can do that, you can convert from any base into our number system. Converting the other way is a little bit trickier. But the key is group by 2. What operation in math looks at groups of stuff? There's 2 of them. Our main operations are addition, subtraction, multiplication, and division. What operations are about grouping stuff? Multiplication or division? Yeah. If I'm searching for groups, that's division. If I'm calculating given groups, that's multiplication. So when I'm converting from our number system to any other, I'm searching for groups of stuff. So I'm going to have to use division. So let's try this together. Let's pick a number. Let's see, we just did 21. How about we try 53? So we're going to take 53 and base 10, and we're going to try and change that into a base 2 number. To do that, we have to look for groups of 2. So there are 2 ways to do it. One way is to think about, anyone ever a cashier anywhere? So you have to count back change sometimes, right? Don't you give the biggest piece of change possible first? Like if somebody, you owed them 63 bucks, would you start dishing that out in ones? No, what would you do first? You'd probably go for your 20s. And then you'd use your 10s, and then 5s, and 1s, then you move over to your coins, right? So you could view this as counting back change in base 2. So you'd have to say, okay, what's the biggest place in base 2 I could use here? So then I have to start thinking about base 2 places. And where'd they go? Here they are, okay. So we get up to 16s. What's after 16s?
6.
Double 16, and we get
32.
32s. And after 32s is 64s. Are 62 4s too big for this project? Right, 64 is too big, right? So we have to start with 32s. So we say, okay, how many 32s are in 53? Well, there's 1, but not 2. And that's going to leave a remainder of what? Oops, sorry. 23? Did I subtract right?
21.
21, correct. I did not subtract right. Glad you were watching. So I have 21 left over. Okay, so I did my 16s. What's right below the 16s?
8.
Sorry, what's right below the 32s?
16.
There we go, 16s. I got ahead of myself. Can I use 16s with 21? So right now, well, let me do this first. So 16 goes into 21 how many times? Once. Now in base 2, it either goes in once or none, because they only have ones and zeros to work with. It's always going to be that way. 1 times 16 is 16, subtract, and I get a 5. So let's just make a note where I'm at here. I've got 132. I just found 116. Now I have 5 to work with. What's right below the 16s? 8s. Can I use 8s? So I have to say no 8s. Can I write that down? Okay, right below the 8s is the 4s. So I say, okay, can I take 4 into 5? The answer is once. 1 times 4 is 4, subtract, and I get a 1. So let's see, I found 1, 4. What's right below the 4s? 2s. Do I need any 2s? Nope. And I now have 1s left. So my claim is 1, 1, 0, 1, 0, 1 in base 2 means the same thing as 53 if I did that right. Could I have screwed this up? How many people do this often? Besides Tiffany. No. Yeah, I don't do it often either. I could have totally screwed this up. So I better expand this to make sure I did it right. So let's bring up a new page and try and expand it. 1, 1, 0, 1, 0, 1, I think is what we had. Yeah. In base 2. All right, so I'm going to go over here. I have 1, 1, and no 2s. And 1, 4, and double 4, and I get no 8s. 116, and 132. Okay, so that gives me 32 plus 16 plus 4 plus 1. So that gives me 10, 11, 12, 13. Carry the 1, 3, 4, 5. Yep, it works out to 53 in base 10. So one method is, again, pick the biggest place value that works and start dividing, and then look at the remainder for the next place value. You just keep working your way down. Here's another really cute way to do it. And we'll talk later about why it works. Instead of looking at the highest place value, you just think group by 2, because that's all you have to do, right? So I start with 53, and leave a little room above your 53 so you can work this out. And we're going to do what's called short division instead of long division. With short division, you don't write anything underneath. Okay? So 2 goes into 5. How many times? Twice. With 1 left over. So in short division, we just do the subtraction in our head and write the remainder like that. Then I say, okay, 2 goes into 13. 6 times, and then I go remainder 1, like that. So what did I find? In 53, there are 26 groups of 2 plus 1 left over. Now, what I've done is I've taken 53 ones, and now I have a whole bunch of packages of 2. If I start looking for groups of 2 2s, what have I just moved up to? My 4s, yeah. So we just keep dividing. So then we say, all right, let's start looking for groups of 2 in those 26 groups of 2. And we just divide again. 2 goes into 26. Let's see, 2 goes into 2 once. 2 goes into 6, what, 3 times? Remainder, 0. And we do it again. 2 goes into 13. Let's see, how many times? 6 times. Remainder 1. Do it again. 2 goes into 6. 3 times. Remainder 0. Keep going. 2 goes into 3. Once. Remainder 1. Keep going. I'll tell you when we're done. Let's try blue. 2 goes into 1. 0 times. Remainder 1. Yeah, you're done when you get that 0 quotient at the top. That says, ding, you're all done. Now, look at the numbers I've accumulated down that way. What can you tell me about all those remainders?
It's the same as.
That's the number we just calculated by looking at the repeated division. So it's just a slightly different way of organizing the division, but it says, hey, there's your answer. It's 1, 1, 0, 1, 0, 1. Why does this work? Well, it's all about grouping. So just note, at this point right there, that 26 is groups of 2. Right? I started with 53 ones, and that first division by 2 said, let's bundle a whole bunch of packages of 2 up. Oh, we got 1 extra. Then we start looking for groups of 2 in the groups of 2. 2 groups of 2 is 4s, so the 13 must be 13 4s. So basically, as we repeatedly divide by 2, we get our groups of 2, then we get our groups of 4, and then our groups of 8 and 16, on up the line, until we run out of groups of stuff and have a remainder left over. So there's the counting back change method, and then there's the repeated division method. All right, let's switch to another number system. We are going to count in base. What base do you want to do, Caleb? I don't know. Tiffany, pick a base.
7.
7. Ooh, not what I would have picked. Good job. No reason why. I was hoping for 5.
Oh.
7's okay. So we're going to try base 7. And so the first thing we'll do in base 7 is we'll count. And we'll write down the numerals as we count. Now, before we do that, just a couple of reminders. What are we grouping by? We're going to remind ourselves, group by 7. So this is a huge mental exercise. Oh, speaking of mental exercises, for those of you who are cursing me tonight when you're doing your homework here, there's research that shows is if you force your brain to do new things, it has to make new connections. The more connections you make, diminishes the effects of things like dementia when you get older. So it's not going to stop you from getting Alzheimer's. If that's going to happen from environmental or genetic reasons, I'm sorry, I can't help you there. But by training your brain to do new things all the time, you have more pathways. So when a disease diminishes some pathways, you get other ways to get stuff done. Right? So you're less effective on it.
Is this section 2.2 or 2.3?
This is still 2.1.
Oh.
We have not moved on to 2.2 yet.
Could not.
What's that? You started what?
I was trying to do 2.2. Could not.
Yeah, 2.2 is about sets. We'll get to that next.
Okay.
Yeah, we're going to just play with some numbers first some more. So in base 7, we group by 7. And the other thing is we should remember what digits we're allowed to write down. And I usually write those down too. 0, 1, 2, 3, 4, 5. Stop! Right before we get to 7, because 0 counts as a digit. So those are my 7 digits. Caleb, did you have a question or were you just stretching?
No, just stretching.
Okay. So those are my digits. All right. So now we're just going to count. What digit here is like a 9 in our number system? Yeah, the 6. When we see a 6, that always prompts us to jump to a new place. All right. So we've got 1, 2, 3, 4, 5, 6, and then we're prompted to jump 1t or 1, 0. But don't call it 10. Because when I hear 10, you probably think the same thing as I do. You think of the number of fingers that most people have. All right. And then after that, it's going to be 1t1. And then we keep going. 1t2, 1t3, 1t4, 1t5, 1t6. 6 triggers me to jump. What's the next numeral?
2t?
2t or 20, however you want to call it. Yeah. All right, how far have we gotten? Let's see. I have no 1s and two whats? 2 7, so I'm up to 14. The homework, I think for some reason, 15 is the popular number to count to. So you'll have a homework problem, you need to count to 15. I'm almost there. How about I write 15 in base 7?
2t1.
2T1 or 2-1. Yeah. There's the first 15 counting numbers in base 7. Some other things you're going to be asked to do is state what numeral is right before and what numeral is right after. So let's play that game next. So we're going to stick with base 7 for now. And I'm just going to write down some numeral. How about 2 or 3T6? That's a base 7 number. What was right before this number in base 7? What is 1 less than that?
2 or 3, 2, 5.
2, 3, 5? 2 or 3, 2, 5. Yeah, because right before 6 is a 5. That one's okay. What number is right after? Now, after 6, we, base 10 people, want to say 7, but I can't do that here. Because after 6, I have to jump place. So what should be next if I jump? Toward 40. 240. Yeah. And just to double check that, in this number system, if I add a 1 to a 6, it brings me to the next place value. So off to the side here, I'm just going to do a little stacked addition. Let's pick red. So if we're at 2, 3, 6, and we add 1, as good base 7 second or third graders, we know that 6 and 1 is 1, 0, and we just learned to carry that 1, 0. And then I know that 1 and 3 on a good day is 4, and 2 plus nothing is still 2. If anyone gets base 12 in the homework, my apologies, it's a pain in the butt. It comes up sometimes. We'll take a quick look at that and then we'll move on to Mayan numbers. Base 12. Base 12 is kind of like base 16 for us base 10 human beings because we run out of digits, right? We hit 9 and then we're like, ooh, we don't have any extra digits. So we have to create new digits. So in base 12, again, we're going to group by 12s. My digits, starting with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 digits. I need 2 more. And the traditional ones to do are A and B. Alternative to A and B would be a T and an E. Which do you prefer, A and B or T and E? For A and B? I prefer T and E. Anybody guess why?
10 and 11.
10 and 11. Yeah, it helps me remember. 10 and 11. Now, A, B is not too bad either because I know A and then B has to go after. So that makes sense too. So they make sense in both ways. I'm going to stick with T and E because that's most likely where you can see in the homework if it pops up for you. And the homework's a little bit randomly generated. So like when Kristen brings up her homework, hers might force her to do base 2 and base 8. But when you bring up yours, you might get base 5 and base 9, and you might get like base 7 and base 12. Right. So people get base 12, they get a much harder problem to deal with. And again, my apologies. You'll be that much better off as a human being with a big brain. Okay, so now we have those digits to work with. So counting in this number system, let's see if we can count up to 15, writing them down. So at the beginning is always easy. 1, 2, 3. It's when you start to reach your group limit that you struggle. 4, 5, 6, 7, 8, 9, T. And then E, and E is my flag because that's like a 9 now. So what do I write down next to say 12 in this system? 1, 0 or 1 T. Yeah, one group of 12 and no ones. I jump. And then I count up from there. A 12 and a 1, a 12 and a 2, a 12 and a 3, is what that means. Let's see, a 12 and a 3 in our number system would be what? 15. Okay, so I can stop. I get to the magic number 15. Okay. And then this thing is going to continue. So let's suppose we skipped a bunch of numbers and we ended up getting to EE. What's going to be after EE? So remember, E is like a 9. We have to jump. So it's going to be like 100, but we're just going to call it 100. Okay. So let's think of how, in our number system, how much is 100? Well, let's see. We have our 1s. We have our 12s. What's the next place? 12 12s or 144. Yeah. So here, if we count it up to, so this is base 12. That's the same as 144 in base 10. Same amount of stuff, it's just a different way of grouping it together. Instead of grouping by 10s, we're grouping by 12s. All right, let's take a quick look at Mayan, and then we can jump on to some stuff from section 6.2.
I have a question.
Yes, sir.
So why'd you put a T and an E? I'm still confused by that.
So we're in base 12, so we need 12 digits. I'm trying to use something familiar to you, so I use 0 through 9 because you're familiar with them. 0 through 9 gives me 10 digits. I need 2 more digits. A digit has to be a single symbol.
Okay.
So I need 2 more symbols to use. Sometimes in books you'll see them use a T and an E, and others they'll use an A and a B. And I chose T and E for 10 and 11. So for example, let's just give an example. Suppose I saw the number ET3 in base 12. And I want to figure out what the heck does that mean in base 10? All I have to do is be able to name the place values. So the 3 is in what place value? The 1. So I have 3 1s, and the T is in which place value? The 12s. So I have 10 12s, and the E is in which place value? The 144s. So I have E is for 11. Oh, how'd you get up there? Interesting, glitch in the computer. So I have 11 144s is what that number tells me in base 10. So then I just clean that up. So let's see, I'm going to have to multiply. That's 144 and 1440, which is 485, 1,584. Add that to 120 and then a 3. So altogether, I think that represents 7, 0, carry the 1, 6, 7. That's the same thing, if I did that right, as 1,707 in our number system. So it's just a different way of grouping. So imagine that instead of evolving with 5 fingers on each hand, we evolved with 6 fingers on each hand. This is what we'd be doing instead. And it would be as familiar to us as base 10 is right now, because we would have just grown up counting that way, grouping that way. Be no big deal. Okay. In our number system, what's the easiest number to multiply by besides 0 and 1? 10, right? Because you just throw a 0 on. So guess what number would be the easiest thing to multiply by in base 12? 12. Because how do you write 12 in base 12? Right? That's one group of 12 and no 1s. So multiplying by that's easy. You just throw a 0 on the end. You just jump place values. Okay. 10 is easy in our number system because we group by 10. That's the only reason 10 is nice. There are some numbers that have special properties regardless of the number system. There are other numbers that have special properties only because they're in that number system. So for example, 10 is only special because we group by 10. 9 is only special in our number system because we group by 9. But prime numbers are prime in every number system. Doesn't matter whether it's binary or hexadecimal or even Mayan. primes are still special. All right, Mayan, let's take a look at it. Mayan number system's a little different. They have a base 20 system. So they group by 20s. They only have 3 digits. Their digits are a clamshell, which represents 0, a pebble or dot, which represents 1, and a stick or a bar that represents 5 things. Other thing about Mayans, where we write our numbers with the smallest place value to the right and move to the left, the Mayans write their smallest place value at the bottom and go up. So with Mayan numbers, their groups jump up. You always start with the 1s. Next place is always the base. What base are we here? 20. So the next has to be my 20s. 20. And then we're grouping by 20. So the next place would be 20 groups of 20, which is 400s would be the next place. I'm just going to write it that way. So I'm going to write a couple numbers in Mayan and see if we can decipher them. So let's suppose we had saw that right there etched into some stone. So the first thing I would have to decide is, okay, what are my place values here? And given that there's a 0 in the middle, I'm guessing, oh, by the way, that dot's kind of light. Let's make that a little bigger. Come on, that's better, okay. So I'm gonna guess I have 3 place values shown here. I have this one, and this one. And another reminder to myself, I have my 1s, I have my 20s, and I have my 400s. And once I've identified the place values, I can go calculate out this number in base 10. So, help me out here. How many 400s does it look like I have? 6 400s, yeah, 6 400s. And then how many 20s?
0.
No 20s. And then how many 1s? 17, right? 5, 10, 15, 16, 17. So I have 17 ones. Yes, sir.
So does it always go by 20s?
Mayan number system, sort of. So there were 2 versions of the Mayan number system. There was the commoner's number system, the commerce number system, and then there was the religious/scientific number system. In the common one, the commerce one, they always went by 20. In the religious/scientific one, from this step right here, instead of multiplying by 20 to get the next place, they actually multiplied by 18. What's 18 times 20?
360.
360. 360 is close to what famous number? Actually, 360 is famous in its own way, but it, what's that? Yeah, days in a year. So the Mayans knew how many days there were in a year. They knew there were just over 365 days. Right? They knew it was like they had leap years. They knew that idea. And so their scientific religious system was all about tracking the stars, which means it was related to this stuff here. So their year had, I think it was 18 20-day months, plus a 5-day, I think it was their harvest period. And then some years that got an extra 6th day to account for the leap year thing. So they had a pretty advanced calendar system. They had a slightly different number system in talking about the calendar, which related to religion and science. But in commerce, they strictly went by 20s. So if we went with the commerce version, which is what I'm going to stick with, what would the next place after 400s be?
8,000.
8,000, yeah, so 20 times 4, 2 times 4 is 8, put another 0, so it'd be the 8,000s would be the next place. Yeah, so let me just finish this number here. Let's see, we have 6, 400, 6 times 4 is 24, so that's 2,400. No 20s plus 17, so this would be 2,417 in our base 10 system. And Mayans were one of the first civilizations to have the idea of zero. So when the Mayans were doing these complicated calendars and using zero to represent big numbers with place value, the Europeans were still using Roman numerals and not making much progress in science because Roman numerals are a pain in the butt. Imagine doing multiplication with Roman numerals. No fun. Don't want to do that. All right, so that's enough information there to get you going with your homework in 2.1. You should be able to get most of it done with that. We have a few questions to work out. Let's take a look at some stuff in 2.2, and then we're going to work on activity 1 and 3. So that was all from 2.1. I'm going to make a second recording for this, actually. So let me stop and restart. If anyone needs a pod.